In this video, we're computing the derivative of the inverse tangent function. So the way to get a handle on inverse functions generally is to just give them a name so you can turn them around into an ordinary function. So if we want the derivative of the inverse tangent function, we're going to give that a name and we'll just call it y. So y is equal to the inverse tangent or arctangent of x. Now a really useful way to read that is that y is the angle whose tangent is x. So with y being the angle whose tangent is x, we can write tangent y equals x. Now what we're going to do is differentiate both sides of this equation with respect to x. And that's justified because if two functions are equal to each other, then surely their derivatives are equal to each other. So on the left-hand side, we want a derivative with respect to x of the tangent of y. And we have to remember here that y is a function of x. So the tangent of y is really a function composition where the inner function is y. This means when we take the derivative of tangent y with respect to x, we have to use the chain rule. So we start out by taking the derivative of tangent y with respect to y, and that gives us secant squared y. But then we have to tack on the derivative of the inner function with respect to x, in other words, dy dx. And dy dx is actually exactly what we're looking for in this problem. Y is the inverse tangent of x. Dy dx is the derivative of the inverse tangent function. So we're going to try to isolate that dy dx in just a second. On the right-hand side of our equation, we had a derivative with respect to x of x, which is just 1. So now we isolate dy dx. Again, that's our ultimate goal in this problem, is to compute that derivative. And that's 1 over secant squared y. Now the secant function is 1 over the cosine function. So if I have 1 over secant, that's the same as cosine. So we can simplify this right-hand side to the square of cosine y. So cosine squared y. And it might be a little more clear to just rewrite that as cosine y all squared. That means exactly the same thing as putting the 2 right above the cosine. So what we need to do is find the cosine of y and then square it, and we've got our derivative. But remember, y is the angle whose tangent is x. It's the inverse tangent of x. So our derivative is going to be the cosine of the angle whose tangent is x, all squared. And this is a classic situation where we find ourselves having to evaluate a trig function of an inverse trig function. Remember, an inverse trig like this, inverse tangent of x, is actually an angle. And what we want is the cosine of that angle. And my favorite way to do this is to visualize that angle in a right triangle. So here's our right triangle where we're trying to visualize the angle whose tangent is x. So we're going to make that this angle right here. So if the tangent of that angle is x, the simplest way to make that happen is to make the opposite leg of the triangle x and the adjacent side 1. Now the tangent of that angle is opposite over adjacent, or x. Now to get the cosine of the angle whose tangent is x, we still need to get the hypotenuse. And when you get used to it, that's just a guess and check game. I can look at this and think about enforcing the Pythagorean theorem, and I realize that the hypotenuse must be the square root of 1 plus x squared. So that when I look at the Pythagorean theorem, I have the sum of the squares of the two legs, 1 squared plus x squared, is equal to the square of the hypotenuse. Now, if you're not seeing that, you can always solve for the hypotenuse explicitly in an algebraic way. And to get that done, I just need a name for the hypotenuse, and I'm just going to call it question mark. And then I state the Pythagorean theorem. So the sum of the squares of the two legs, 1 squared plus x squared, is equal to question mark squared. And when I take the square root of both sides to solve for question mark, I arrive at the same value for the hypotenuse. That's the square root of 1 plus x squared. Okay, now that we have that hypotenuse, we should be able to find the cosine of the angle whose tangent is x. Cosine is the adjacent side over the hypotenuse. So that's going to be 1 over the square root of 1 plus x squared. And finally, all we have to do is square this expression, which undoes that square root. And we arrive at an algebraic expression for dy dx. In other words, we found the first derivative of the inverse tangent function, and we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.